Let's review a little bit about what we know so far about subtraction. So if I say 5 minus 3, what does that mean? Well, there's a couple of ways to think about it. I could have 5, let's say I had five berries. So 1, 2, 3, 4, 5. So I could have 5 berries. And when I say minus 3 or subtracting 3 from it, I can view that as saying I'm going to take away 3 of these berries. So if I take away that berry, and that berry, so I've took away 1, 2, 3 berries, how many berries do I have left? Well, the only berries I have left are right here, 1, 2. So I have 2 berries left, just like that. Now the other way that I could visualize or think about 5 minus 3, I'll do it over here. 5 minus 3 is to think about what the difference between 5 and 3 is. So let me do this. So let's say I have 5 berries. 1, 2, 3, 4, 5. And let's say that you have 3 berries. Yours is a slightly different color. You have 3 berries. So another way to think about 5 minus 3 is how many more berries do I have than you have? And if you look right here, well, you see this berry is another. You have also 1 berry there. We both have 1 berry there. We both have 1 berry there. But I've got 1, 2 berries that you don't have. So once again, I have 2 more berries than you have. Now we can also think of this from the number line point of view. The number line point of view. So let me draw a number line. Just like that. It's my number line. We've learned on the addition videos we can keep going off forever. And actually, we could even go to the left of 0 and go into negative numbers, which we'll see in future videos. But I'll start at 0. 0, 1, 2, 3, 4, 5. I'll go up to 7. So if we do 5 minus 3, if we view 3 as being taken away from 5, 5 minus 3 means start at 5. If I did 5 plus 3, I would jump 3 spots to the right, because that's increasing the number of things I have. But since I'm subtracting 3, I want to decrease by 3. So I decrease by 1, 2, 3. And I get to 2, just like that. Now, if we visualize it from this point of view, let me draw another number line. And I wanted to show you, I'm taking away 3. And here I'm saying how many more is 5 than 3, even though they're the exact same answer, but there are 2 different ways to think about it. Let me draw a number line here again. Let me draw the same number line. I'll draw the same number line. I have 0, 1, 2, 3, 4, 5, 6, 7. So if I were to plot where 5 is on this number line, so this is the 5 right there. I'll put a little pink square around it. 5 is right there. Now 3, let me do 3 in this yellow color. 3 is right here on the number line. So in this way of thinking about 5 minus 3, you're saying what is the difference? Let me write that down. Here we're saying, what is the difference? The difference between 5 and 3. Between 5 and 3. And to figure out the difference, you actually have to say, how much do you have to add to 3 to get to 5? So the difference here, how different is 5 than 3? Well, you have to go up 1 and then up 2 to get to 5. So the difference between 5, which is all the way over here, and 3, which is just that far, is the difference between 5 and 3 is 2. Just like that. That right there is 2. Let me draw that in another box. So that's 2 right here. And I want to make this difference between subtraction and difference, I want to make it at least reasonably clear to you, because these are 2 different ways of viewing subtraction, but it ends up being the exact same operation. You're going to get the same answer regardless of which way you think about it. Now, I could view, let me do different numbers now. Let me do 7 minus 4. So I could view this as maybe I have a 7-foot long piece of wood. Maybe I have a 7-foot long piece of wood. It's 7 feet long. If I put a ruler up against it, I would have that's 0, 1, 2, 3, 4, 5, 6, 7. So I have a 7-foot long piece of wood. And then I could saw off 4 of those feet. So if I were to saw off 4 of these feet, so I saw off 1, 2, 3, 4. How much wood do I have left? So all of this stuff right here, I'm eliminating. I'm sawing it off. I'm sawing it off of the wood. Maybe I should do that in a darker color to show that I'm sawing it off. So all of this stuff is going to disappear. I'm grinding it away. I'm sawing that off. So I'm just left with, after I saw off the 4 inches or feet or whatever of the wood, I'm left with 1, 2, 3 inches of wood. So this is 3. So 7 minus 4 is equal to 3. This is viewing subtraction as literally taking away. I sawed off the wood, so I took away wood. Now, I could think of it in a slightly different, a slightly different way of thinking about it, but give you the exact same answer. We could say 7 minus 4. So once again, I could have the 7-inch long piece of wood, right, like that. So if I put a ruler here, that's 1, 2, 3, 4, 5, 6, 7. So once again, a 7-inch long piece of wood. And now, instead of taking 4 away of it, I'm comparing it. So that's a 7. I'm comparing it to a 4-inch long piece of wood. So I have another 4-inch long piece of wood right there. That's my 4-inch long piece of wood. That's 7. This is 4. You could view 7 minus 4 as taking 4 inches away from the long piece of wood, or you could view 7 minus 4 as the difference between the 4-inch piece of wood and the 7-inch piece of wood. So in this case, what's the difference? To go from the 4-inch piece of wood to the 7-inch piece of wood, I would have to grow by 3 inches, or I would have to add a 3-inch piece of wood somehow, or the wood would somehow have to grow by 3 inches in order to become 7 inches. So these are two completely equivalent ways to view subtraction. That's all a little bit of review from the last video. Now, what I also want to do in this video is start tackling slightly larger problems, but you'll see that the number line applies just equally as well as to kind of the simpler problems that we've done before. So let's do 17 minus 9. So just like everything else, there's 2 ways we could have done it. The more slow way is you could draw 17 objects. Let's say I have 17 chips. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then I'm going to take away 9 of them. So I'm going to take away 1, 2, 3, 4, 5, 6, 7, 8, 9. How many am I left with? I'm left with 1, 2, 3, 4, 5, 6, 7, 8. So 17 minus 9 is equal to 8. But that took a long time. And you can imagine if this number was a lot bigger, it would have taken me forever to draw all of these circles and then scratch out things. And it would have wasted paper and time. And well, we have other things to do. So another way you could do it, and maybe this would be easier for you to visualize, is to draw the number line. You always don't have to start at 0. So if we draw the number line, if we say, let's say that's 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7. You can imagine I could keep going to the left all the way to 0. But I start at 17. I could start at 17 and take away 9 from it. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. And once again, we are left at 8. Now, this was, at least in my head, a little bit cleaner and faster than this one. But in either case, you don't want to do this every time you have to subtract 9 from 17, or want to find the difference between 17 and 9, and to realize that's 8. So this is something that eventually you'll want to internalize. You'll want to know by heart that, oh, 17 minus 9, I know that is 8. And by the way, 17 minus 8. What's 17 minus 8? Well, that is 9. And now why does all of this make sense? Because 8 plus 9 is equal to 17. So 17 minus 9 is 8. 17 minus 9 is 8. Or 17 minus 8 is 9. When I say 17 minus 8, I'm essentially saying that is equal to some number that if I were to add to 8 will equal 17. Well, that's 9. And when I say 17 minus 9, that's saying there's some number that if I were to add it to 9, I'll get 17. Well, that's 8. So all of these statements are kind of saying the same thing, that 8 plus 9 are 17, or the difference between 17 and 9 is 8, or the difference between 17 and 8 is 9. Hopefully I'm not confusing you. So for most of these subtraction problems where the answer is a one-digit answer, you should eventually have them memorized. But in your head, it's good to be imagining this number line. Let's do a couple more of these. And then once we have these memorized, or at least be able to do a number line if we forget, I'll show you how to do any subtraction problem for arbitrarily for super large numbers. So let's say we're going to do 13 minus 5. So once again, I'm not going to do the whole circles or the berries this time. I'm just going to draw the number line. Just draw the number line like that. And let's start at, no, it says 14, 13, 12, 11, 10, 9, 8, 7, 6, 5. And you just keep going lower and lower. You can go to 0, or you could even go past 0. We'll talk about that in the future. But we start at 13. We're starting at 13. 13. And we're going to take 5 away from it. So this is the subtraction view of subtraction. We're taking away 1, 2, 3, 4, 5. And we land at 8. So 13 minus 5. Let me do this in a new color. 13 minus 5 is equal to 8. Now, another way we could have thought about that, I plotted where 13 is. I can plot where 5 is. I could say, look, this is 5. 5 is right here on my number line. What do I have to add to 5 to get to 13? So let's see. I have to go 1, 2, 3, 4, 5, 6, 7, 8. I have to add 8 to 5 to get to 13. 5 plus 8 is equal to 13. So that tells me that 13 minus 5 is equal to 8. This also tells me that 13 minus 8 is equal to 5. These are all of these are on some level telling me the exact same thing, that the difference between 13 and 5 is 8. The difference between 13 and 8 is 5. 5 plus 8 is 13. So hopefully you have the hang of that. And if you haven't done so already, it'll be good to practice all of these, taking a teen number and then subtracting any of the one-digit numbers from those teen numbers. That's in general very, very good practice for you.